Hey everybody, we are finishing up our hypothesis testing and we're going to finish with a claim about a standard deviation. Two requirements that we're going to need for that. We could also test the variance, but we're only going to do standard deviation for this talk. The sample has to be simple random sample, but the more important is the population has to be normally distributed. And we have a list below of heights is a random sample of supermodels. We're going to use here's our alpha, our 0.01 significance level to test the claim that supermodels have heights with a standard deviation that is less than 2.6 inches. So let's write our null hypothesis. Remember, our null hypothesis is always equals. And again, they want to test that it's less than 2.6. So once again, this is the claim. Now this one has a chi-squared graph. So if you remember, the chi-squared graph starts at 0 and is very skewed to the right. And because we have a less than, that's going to be here only. So once again, this area is our alpha, which is 0.01. And we need our critical value. Now for this, I'm going to need a table. So with chi-squared, and with this table, this is area to the right only. So area to the right of this point is going to be 0.99. So that's what I'm going to actually look up. 0.99 is here. If you remember the degrees of freedom, so in this case, n is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N is 10, which means the degrees of freedom is 9. So I'm going to use my table. 0.99 to the right, degrees of freedom of 9. So here's my value right here, 2.088. That's my critical value. Now I need my test statistic. So, test statistic. And if you remember, back in a previous talk, I gave you this table. And here is our test statistic for a chi-squared. Now remember that S here is the sample standard deviation, which we'll have to get from the data here in just a second. And our sigma is right here, our 2.6. So what I'm going to do is I have this in my list of list 1. I have these supermodel heights, and I'm going to calculate a one variable stats on list 1. And that's going to give me my S. So S in this case, I'm going to go to 4 decimal places, 0.7997. Plugging that into here, I'm going to have 10 minus 1 times 0.7997 squared over my 2.6 squared. So this is going to give me 9 times 0.7997 squared divided by 2.6 squared, giving me a test statistic of about 0.85. And you will note 0.85 is in the critical zone. So because it's in the critical zone, we are going to reject the null hypothesis. So reject. Push that up. So there is sufficient evidence to support the claim that supermodels have a standard deviation less than 2.6. Next up. So here we have some speeds measured from southbound traffic. Here's our alpha. 0.05 in this case, significance level to test the claim that the highway speeds equal 5 miles an hour. Standard deviation, pardon me, speeds are 5 miles per hour. So our null hypothesis is that sigma is equal to 5 miles per hour. Our alternative hypothesis is that it is not equal to 5. That's going to make this a two-tailed test. And we'll draw our chi-squared graph again. Now, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. N is 12 in this case, which means my degrees of freedom is 11. This tells me that I'm going to have a two-tailed test, so I'm going to have two critical values. So remember, with my table, it is always area to the right. So this is going to be my chi-squared left. Left and chi-squared right. I'll start with the right one because there's 0.025, 0.025, degrees of freedom of 11. That brings me here 21.920. Double check that here. 11, 21.920. Yes. And the left one is going to have, so if I add this up in here, is 0.95. So area to the right here is 0.95 plus 0.025, so that's 0.075 if I add these two up. 0.975, again, with the degrees of freedom, I have 3.816. 3.816. Meaning if my test statistic is between here and here, then it is failed to reject. If it's in the critical zone, then we're going to reject the null hypothesis. So let's get our test statistic. I'm going to use the same one as above. So chi-squared, and I need to get the standard deviation. I've already loaded the data into my list 2, so you may need to pause this video to do that. So I'm going to run one variable stats on my list 2. If you put it into your list 1, then you would do it against list 1, of course. And there's my standard deviation. So standard deviation of the sample is about 4.075. So here we go. N minus 1, n in this case again is 12. minus 1 times 4.075 squared over 5 squared. And putting it all together, that's 11 times 4.075 squared divided by 25, that's 5 squared, gives me about 7.306. Which you can see is definitely between these two here. So 7.306. So that means we are going to fail to reject the null hypothesis. The null hypothesis, so there is not sufficient evidence to support, it's a U, support the claim that the standard deviation speeds is equal to 5 miles an hour.